let's get into to this stuff. I like to talk about vulnerabilities, and I also like I guess I also like 90s SNL and drawing pictures. So I'm going to show a lot of pictures today. Here's a fleet server. We're going to do a bit of a recap on vulnerability management. So from a very high level, very familiar slides. If you saw maybe some past slides, Fleet does a very good job of ingesting and detecting software and operating system versions on hosts. We use that information and we pair it with a bunch of vulnerability data that we gather from various sources. Right? Here's kind of our main sources. NVD being kind of the big cloud here, and that's because it's our largest source. And we're going to talk about that a little bit. So some bad things happened in NVD land recently, February in particular. Here's an article from Info Security magazine last month saying there was the NVD saw disruption. It specifically sees CVE enrichment on hold. So you may be asking, what is CVE enrichment? So here's some sample data. This is directly from some abridged data, directly from the NVD feed. So we have CVE identifiers. Everyone should be familiar with that. We have some metadata. In particular, check out vuln status is analyzed. That means it's been processed by the NVD. And one of their processing steps, their enrichment steps, is to create these software matching rules. And we use this to match Fleet software to vulnerabilities. And so in this case, we're matching the earlier versions of Chrome to this vulnerability. And that's good, right? That works for us. Here is what we've been seeing as of late in the last month or two. The CV does exist in the feed. If you notice in the metadata, we have awaiting analysis. And kind of the biggest red flag here is, oh, we don't have any software matching. So that should cause some concern for anyone using Fleet and the NVD data in general. I'm gonna read this out because I think it's a good summary from the Vulners blog just this week. Since February 12th, the NVD added more than 7,000 vulnerabilities. Only just over 400 of those were enriched with crucial information. And what we care about is CPE. That is what they're referring to as our kind of our matching logic that we use. And you see kind of the graphs kind of level off there, where there's a lot of kind of pending or a lot of CVEs awaiting analysis. And what does this mean for Fleet customers? It means we can't detect those vulnerabilities, right? So before we declare the end of vulnerability management as we know it, there's some hope. VulnCheck and more recently, as early as this week, a company called Vulners both have started enriching their feeds. VulnCheck in particular provides a NVD feed that they enrich with their own data. And so we're going to kind of looking at this NVD again. So what are we going to do as of next release, this upcoming release? We're going to add VulnCheck data. In particular, we're going to add missing matching data that VulnCheck provides into our NVD data that Fleet grabs. So you may be wondering, what do I need to do to get this new data? Do I need to open up firewall ports, proxies to VulnCheck? No, we don't need to do that. But before we get to that, I'm going to kind of talk about at least the NVD API. So when you set up a new Fleet instance and you have vulnerability management on, first thing it needs to do is grab all the data that NVD has. This takes about 17 minutes. And that might not seem like a long time to some of you, but in development, that is an eternity. For new customers trying out Fleet for the first time, that's a very long time to wait to get value from Fleet if you're looking for vulnerability data. Compound that with 17 minutes is really kind of best case scenario, what we found. The NVD API has been somewhat unreliable, so we have a fair amount of retries that happen that really kind of bump up that 17-minute time. So Going back to this kind of original slide, this isn't completely accurate. That's a bit of a summary. What Fleet looks like today looks more like something like this. So Fleet servers grab information from NVD, and we have a Fleet managed GitHub repo that aggregates and pulls vulnerability data from other sources, and that's how it's used today. GitHub has I think we want to build upon the success and reliability of the GitHub platform and API, and so things are going to look like this at a high level. And so customers should not need to open up new firewalls, proxies. They should already have existing communication with GitHub. Granted, this is another repo, so I want to point that out. We're using 2 repos to grab this data, but one source, one place to get all the things. And so we're talking about sync time. What does this do to our initial sync time? It brings it down like quite a bit. The data is already there. It's already pre-processed. It's already enriched. It's just grab the new data. So what's the impact? As of yesterday, this is very, very dynamic. As of yesterday, we've seen over 5,000 new matching rules. So that's, I think, a welcome change to folks looking for worried that they're not worried that vulnerability scanning isn't getting as much as it should. I'm gonna have the quickest demo on earth because it's not the sexiest demo, but we're gonna go to Fleet. This is in dog food, by the way. Thank you for deploying that before demo day, because I found this. Here's a CVE. If I look up the CVE in NVD, it is awaiting analysis. So NVD, just some proof that NVD does not have the information we need. So, but we matched it anyway. Thank you, VulnCheck. Just to show a little bit of contrast on what it would look like for an older CVE. I'll go down to the bottom here. Here's what the matching data looks like. And that's it for me. Thanks, everybody.